Everyone. Today we'll be discussing the LeetCode problem of the day, increment submatrices by 1. So here you're given a positive integer n, indicating that initially we have an n cross n zero indexed integer matrix, which is initially filled with all zeros. And you're also given a 2D integer array query for each, in each row, it consists of row 1, column 1, row 2, and column 2. So you are given n, so you have to build an n cross n matrix with all zeros. And in the queries, you are given row 1 column 1 and row 2 column 2. Suppose you are given this submatrix. So this is row 1 column 1, this is row 2 column 2. So for this query, you have to add 1 in all of the cells of this submatrix. So initially it's all 0. So for this first query, you need to add all ones in this submatrix range. So add 1 to every element in the submatrix from top left corner to the bottom right corner. And after performing all the queries, you have to return the matrix. So suppose the second query can be something like this. It will be this submatrix. So in this submatrix, you need to add all the ones, and at the end, just return the resulting matrix. Let's go over the input, first input. So n is 3. So you have a 3 cross 3 matrix. And your first query is 1, 1, 2, 2. So this is the first row, first column, and this is the second row, second column. So in this submatrix, you need to add all the ones. So if we update it, it will be something like this, all ones added here. And you have the second query from 0, 0 to 1, 1. So this is 0, 0, and this is 1, 1. And you need to add 1 to all the elements in this submatrix. So when you do that, this will be 1, will be 1, will be 1, and this will be 2. So you just have two queries. So this is the final output. And if we check here, 1, 1, 0, 1, 2, 1, and then 0, 1, 1. Let's quickly look at the second input as well. It's a 2 cross 2 matrix. And you only have a single query, 0, 0, 1, 1. So this is 0, 0, this is 1, 1. And you need to add 1 in all of this submatrix. So the resulting matrix will be like this. So this is our output. And coming to the constraints, the n can be up to 500, and the queries will be up to 10 power 4. And of course, the row 1, row 2, column 1, column 2 will be from 0 to n minus 1. Before going to the approach, I just want to quickly explain a concept of prefix sum, which we will be using in this problem. So let's say we have few boxes. Let me just mark them. 0, 1, 2, 3, 4, 5, 6, 7, 8. So we have 9 boxes, index from 0 to 8. And you are given a query saying that I want to add 4 balls from box number 2 to box number 5. So to do this, initially all the boxes are empty. So I'll just write it as 0. And if I see this query, I just have to add 4 balls from box number 2 to box number 5. So for this, I can just iterate from box number 2 to box number 5 and just add a +4 in each of them. And suppose I get another query saying that I have to add 5 from box number 4 to box number 6. So again, for this, I can iterate from box number 4 to 6 and just add a 5. So this will be 9. This will be 9. And this will be 5. So after 2 queries, this is the resultant array after these operations. And each of the query is taking order of n time, because for each query we are iterating from the range starting to the end and just adding the element. So what if there's another technique that is okay, so this is our final array. Let me just take one more query so that it will be a bit more clear. Maybe add a 3 from range 1 to range 3. So this will make 3. Okay, sorry, I lied here. This will make 3, and this will be 7. This will be 7. So the resulting array should be something like this: 0, 3, 7, 7, 9, 9, 5, 0, 0. So after adding all these 3 queries, this should be our final output. Now let's see the other way we can add these queries using prefix sums. So first I got a query saying that I have to add 4 from index 2 to index 5. So instead of iterating from index 2 to index 5, I'll only add the 4 at index 2. And at other indexes, I won't add it. So what this does is, so this will be our array 0, 0, 4, 0, 0, 0. So on this array, if we take a prefix sum, so prefix sum in the sense, for the current element, we'll just add the previous element. So prefix of I is a plus, yeah. So for this array, if I take the prefix sum, so this array will become something like this: 0, 0, 4, and this 4 keeps moving forward. So it will be carry forward till the end of the array: 4, 4, 4, 4, 4. So this is the array, and after performing the prefix sum, we will get this array. But we can see that in the first query, we are only meant to add 4 from index 2 to index 5. But in this prefix array, we can see that the 4 is getting added from index 2 till the end of the array. So to counter this, what we can do is, we need 4 only till index 5. So at the next index, which is 6, I will add a -4 in the array. So what this does is, so to this array, when we do the prefix sum, we have 0, 0, 4, and this 4 keeps carry forward, 4, 4, 4. So it keeps carry forward till this index 5, and once we encounter this 4, so these both will get cancelled, and this will be 0, and the rest of the array will become 0. So now what we saw is, instead of iterating from 2 to 5 and adding 4 at each position, we can just add a 4 at index 2 and subtract the 4 at index 5 plus 1, which is the index 6. And after doing that, when we take the prefix sum of this array, we will get the 4 added in our desired range. So the same thing will apply for the other queries as well. Also, we can see that this query is order of 1 operation, because we are only adding at this and subtracting at the 5 plus 1. And at the end, we are only performing the prefix array operation once. So let's see what happens when we perform all the operations. Let me just erase this. Yeah, the first operation was add a 4 at 2 and subtract 4 at 6. So this is the array. The second operation, add a 5 at index 4. So at 4 you will add a 5, and you want this 5 to be carry forwarded until 6. So at 7th index you will add a -5, so that this carry forward of 5 will stop here. And for the last query, you have to add 3 at index 1. So at index 1 I'm adding a 3, and at index 4 we have to subtract a 3. So it was 5 previously, so 5 minus 3 will be 2. So this is the array we found after adding these queries. And once we have this array, just take a prefix sum of this array, like using this formula. So first we have 0, then 3 plus 0 is 3, 4 plus 3 is 7, 0 plus 7 is 7, 2 plus 7 9, 0 plus 9 is 9, minus 4 plus 9 is 5, and minus 5 plus 5 is 0, and 0 plus 0 is 0. So after taking the prefix sum, we can see that this array exactly matches with our output. So with this, what we can say is we can add the queries at the starting point and subtract this at the ending point plus 1. And at the end, when we perform the prefix array, we will get the desired output. And there's one thing to note here, that suppose you have a query like this. We just write 0, 1, 4, 5. So you have a query like add a 5, okay, add a 7 from index 2 to index 5. 0, 0, 0, 0, 0. So in this case, what we do is first we add a 7 at index 2 and we subtract a 7 at index 5 plus 1. But here we can see that the sixth index does not exist. So we don't need to subtract a minus 7. So let's say we write a minus 7 here. What happens is when we perform the prefix array of this will be 0, 0, 7, 0, 0, 0, 0, 7, 7, 7, 7, and we stop here because the array is only till index 5. So it doesn't matter if we subtract a minus 7 or not, because we are only iterating till here. So this is the corner case. If the right is equal to the last point, then we don't do the subtraction, because it doesn't matter even if we subtract or not. Now let's extend our approach on a 2D matrix. So suppose we want to increment ones from 1, 1, which is this, to 2, 3, is this point. So again, instead of iterating on all the submatrix and adding a 1, we can use the previous approach, where you can add a 1 at this point, which is row 1 and column 1, and subtract a 1 at row 1 and column 2 plus 1. So here we will subtract a 1. And similarly, at this point, which is row 2 plus 1, we will subtract a minus 1. And at this point, which is row 2 plus 1 and column 2 plus 1, we will add a plus 1. So let's see why we do it. Yeah. So for each query, we'll just perform 4 operations. At row 1, column 1, we'll add a plus 1. And at row 1, column 2 plus 1, we'll subtract a minus 1. And this is row 2 plus 1 and column 1, we'll subtract a minus 1. And this is row 2 plus 1, column 2 plus 1, we'll add a plus 1. After doing this, we'll first iterate on all rows and perform the prefix array. So first we'll iterate on the first row and take the prefix array of this row, so it remains same. And now if we do for the second row, so first we have 0, then we have 1, then here it is 0 plus 1, so this gets updated to 1, and this 0 plus the previous element 1, so this is again 1, and here minus 1 plus 1, so this becomes 0. So this is for the second row. Now we do for the third row, so since it's all zeros, it remains same. For the fourth row, we have 0 here, then here minus 1, so this minus 1 gets carried forward. So minus 1 plus 0 is minus 1, again minus 1 plus 0 is minus 1, and minus 1 plus 1 is 0. And finally we do the prefix sum for this row, and since it's all zeros, it remains same. So now we can see that after doing the prefix sum for the row, this one has been carried forward in the entire row, and this -1 also has been carried forward in the entire row. So now the only thing left is to perform the prefix sum on the columns. So we'll perform the prefix sum on the first column, so it remains same because it's all zeros. On the second column, so first we have 0, then we have a 1. So here 0 plus the previous element, so this becomes a 1. And this prefix ends here because you are encountering the -1. So -1 plus 1, this turns out to be 0. And 0 plus 0 is 0. So same thing for this column as well. This 1 gets carried forward here, and 1 plus 1, 0. So the carry forward ends at this point. And 0 plus 0 is 0. And the same thing for this as well. Here you have a 1, and here 0, 0. And for the last column, it's all 0, so it remains same. So you can see that after performing the prefix sum for the rows and then for the columns, the answer has been populated. So in this range from 1, 1 to 2, 3, we have populated all the ones. Now let's quickly code the approach. So first let me create a 2D array. Answer. Its size will be n cross n. And then let's just iterate on the queries. So initially this answer array will be containing all zeros. So query in queries. So from these queries, let's first extract the row 1 and the column 1 for clarity. Row 1 will be query of 0, and then column 1 will be query of 1. And similarly, we can do it for row 2. We can get it from query of 2, and column 2 from query of 3. So from this, we have extracted the row 1, column 1, and row 2, column 2. So after doing this, like we discussed, we have a matrix, and in that, this is row 1, column 1. This is row 2, column 2. So here we need to add a +1. Here we need to subtract a -1. And here we need to subtract a -1. And then move this. And here we need to add a +1. So this is row 2, column 2. So let's just perform all these operations and we can do it in any order. So first thing, answer of row 1, column 1, ++. So this step is done. We added a +1. Now we need to add a subtract a -1. So that is answer of row 1, and then column 2 +1 minus. So this step is done. Now for this -1, it is answer of row 2 +1 and then column 1. So you subtract a -1 from it. So this step is also done. And finally, for this one, we have answer of row 2 +1, column 2 +1, ++. So these are the 4 operations we do for each query. And once it's done, we'll just perform the prefix array. First in the column, in the row wise, and in the column wise. So first let me iterate on all the rows. So for the particular row, we start from j equal to 1 of I j equal to I j minus 1. So for each row I, we are iterating on the row and taking the prefix array of it. So similarly, we'll do it for the columns. So we'll first iterate on the columns. Now in that column, I equal to answer of I, j is equal to -1 and j. So this is the prefix array for each of the columns. And at the end, you can just return answer. But one more thing to note. So we do this operation, but we can see column 2 plus 1 can go out of the array. Row 2 plus 1, so this value can go out of the array. And row 2 plus 1, column 2 plus 1, this value can also go out of the matrix. When suppose the submatrix is something like this. So if it's something like this, then here you add a +1. Let me bring it here. Yeah. So here you'll add a +1. Outside the array, you need to subtract a -1. And here outside the array, you need to subtract a -1. And here also outside the array, you need to add a +1. And like we discussed, if the operations are outside the array, we don't have to perform it. So let's just add a quick check for it to prevent the index out of bound. So since here we are accessing column 2 plus 1, we just need to check if this column 2 plus 1 is less than n. Then only we perform this operation. And for the next operation, we check for row 2 plus 1. So if row 2 plus 1 is less than n, then you can perform this one. And for the final operation, we have row 2 plus 1 is less than n, and column 2 plus 1 should also be less than n. Both of the conditions are true, then only you can add it in this. Let me test it. Test is passed. So before submitting, I just want to quickly dry run this approach for the first input. So first we have a matrix. Let's not draw the box. So we have all zeros. And the first query is 1122. So on this submatrix. So like we discussed, first we need to add a +1 here. And then we need to subtract a -1 here, so it's out of bound. And here also we need to subtract a -1, it's also out of bound. And here we need to add a +1, and this is also out of bound, so no need to do it. For the second query, which is on 0, 0 and 1, 1. So first here we need to add a +1. And then here we need to add a -1. So this term will become -1. And then the next one is row 2 plus 1, column 1 minus minus. So here we need to add a -1. So here we add a -1. And since this is a array, like the last one is pointing to this element. So here we need to add a +1. So the 0 will become a +1. So this is the resulting matrix after all the queries. So first let's perform the prefix array on the rows. So this row will get transformed to 1. Here it will be 1, 0 plus 1, which is 1. And this 1 plus -1, it ends up becoming 0. For the second row, here we have 0. Then here 1 plus 0 is 1, and 0 plus 1, 1. So this 1 gets carried forward here. And for the last row, here -1, and the next 0 plus -1, which is -1. And then -1 plus 1, which is 0. So this is the resulting array after performing the prefix sum of each row. Now we just do the same thing for the columns. The first column, it is 1, then 1 plus 0 is a 1, and then 1 plus -1, which is 0. In the second column, we have a 1, and here 1 plus 1, this is 2, and next -1 plus 2, which is a +1. And finally, for the last column, here we have a 0, here 1 plus 0, which is 1, here 0 plus 1, so this will be a 1. So after doing this is a resulting array, and if we compare the answer 1, 1, 0 and 1, 2, 1, 0, 1, 1, so the answer matches. Let me submit now. This is, I think, row 2 plus 1. Row 2 plus 1 less than n, and column 2 plus 1 is less than n. Yeah, and it works. Finally, let's do the time and space complexity analysis. So for the time complexity, here we are iterating on the queries, and inside the queries, we are just doing constant operation. So this for loop is order of q. And next, we are iterating on the entire matrix to perform the prefix array for the rows. And similarly, we are iterating on the entire matrix to perform the prefix array for the columns. So these two for loops have a combined complexity of order of n square. So the total complexity will be order of q plus n square. And the space complexity will be order of n square, since we are just creating the matrix of size n cross n. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.